No camera. Yeah. So on this audio also. Okay. So a very good afternoon to all for this fourth day of faculty development program on AI machine learning in healthcare research. Their challenges and trends. So I'm warmly welcoming our respected Dr. Khel Chandra Sangam sir from NIT Manipur. It is my great pleasure and privilege to introduce Dr. Khel Chandra Sangam, a distinguished academician, researcher, and educator in the field of computer science and engineering. Uh, he is currently serving as a associate professor in the Department of Computer Science and Engineering at National Institute of Technology, Manipur. He is also an academic dean for NIT Manipur, where he has been contributing significantly to teaching, research, and academic development. His areas of research interest span a wide spectrum of emerging technology, including artificial intelligence, um, machine learning, hybrid intelligence system, image processing, speech processing, mobile, robot navigation, natural language processing, and Internet of Things, and healthcare technology. So, Dr. Khel Chandra Thangam has an immersive academic background with international exposure. He obtained both his PhD and also MTech from the Human Interface Laboratory at the University of IGO, one the premier institute known for advanced research and computing technology. He completed his bachelor degree from computer science and engineering from Northeastern Regional Institute of Science and Technology. His professional journey reflects a strong blend of teaching, research, and industry experience, including the international exposure. International research experience in Japan, mostly as a research assistant and researcher. Over the years, he has served as a faculty member at reputed institutes, including Geetam University, before joining NIT Manipur in the year 2011 as assistant professor, and subsequently he became associate professor in the Department of Computer Science and Engineering at NIT Manipur. With years of education, dedicated contribution to the education at Manipur, Dr. Tengam continues to inspire students and researchers through his expertise in intelligence systems and advanced computing technologies. His commitment to innovation in interdisciplinary and intelligence systems. So please join me in extending our warm welcome and heartfelt appreciation to Dr. Khel Chandra Thangam for agreeing to participate in the FDP and giving an expert talk on the on the topic. So I'm very much thankful for him to to introduce here. So, sir, please continue the session.
So, Dr. Rojal, am I audible?
Sir, you are audible.
Audible. Okay, thank you.
So I have introduced the Professor Khel Chandra, Dr. Khel Chandra Thangam, distinguished academician. So I, I I don't feel is there any audio or anything problem there. Otherwise, I will do again.
So, Dr. Ujjal, thank you very much. So, respected experts, faculty members, staff, and my dear students, a very good afternoon to all of you. So, I will start my presentation. So, today I'm going to talk about mainly about the deep learning and its applications in healthcare. So, these are the contents. I will start with the neural network architecture, like the single layer perceptron, multi-layer perceptron. Then I will come with the deep learning architecture, like the convolutional neural network, then faster RCNN, and after finally we will have a look at some of the applications. So, Dr. Urjal, is it okay? Audible?
Yes, sir.
Yes, yes, sir. You are audible, sir. Yes.
So, artificial neural network, also known as the neural network. So, it is just an information processing system which consists of many neurons. And one neuron is connected to many other neurons. And they work in union to solve specific problems. So, this is the basic structure of artificial neural network. And this also known artificial neural network, also known as ANN. This is going to simulate the working or functioning of the biological neural network, which is inside our brain. So this is the basic definition. Now, whenever we talk about neural networks, two things are there. One is the architecture and one is the learning algorithm. So this architecture, they're developed using these neural models. So one of them is the perceptron model, which is shown in the slide. So as you can see from the slide, the X is the input and W is the weights. So these weights they can be updated or adjusted. So because of this, they have the learning capability. So how it works is this input X is combined with W, and using a output function or activation function, we calculate the output of the neurons. So once we calculate the output of the neurons, after that, what we do is we try to update the weight of the connection with W. So this is the general weight equation as shown in the figure. W is equal to W plus eta delta Xi. So the details I will come in the next slide. So after we update the weight, we calculate the cost function, the value of the cost function. In this case, I gave an example of error function, which is given by half d minus O square, where d is the target output or the desired output, and O is the output of the neurons. So the basic concept is by updating the weight, we try to minimize the difference between these D and O, these two outputs. That is the main concept now. So this is one of the learning rule or learning algorithm, the delta learning rule. So here we use the general weight equation, W is equal to W plus eta delta Xi, where eta is a learning constant between 0 to 1, and delta, we call it the learning signal. And it is given by D minus Fs, F dash ist. So where Fs is the output function and F dash S is the derivative. So this delta is a very important parameter, the learning signal. So how it has been derived depends on the learning algorithm. And D is the desired output or the target output. So this is mainly we use for supervised learning. This is the delta learning. So sigmoid function, we have two types. One is the unipolar and one is the bipolar. Unipolar, the output is between 0 to 1, and it is given by fs equal to 1 by 1 plus exponential minus lambda est. This est is nothing but the combination of this input x and the weight w. So bipolar, the output is between minus 1 to 1 and is given by fs equal to 2 by 1 plus exponential minus lambda est minus 1. So as we can see, if the value of lambda increases, the distance between this horizontal axis and the curve become closer and closer. Now, let's have a look at this single layer perceptron, which is one of the neural network architecture. Here, we use one output layer of neurons given by the red dots. So also we have one input layer. So X is the input and W is the weight of the connection from the input to the output neurons. So D is the target output or the desired output, and O is the output of the neuron given by the equation. So to train this single layer perceptron, we can use the delta learning rule. So this is the basic steps of the delta learning rule, where, as we can see, the first step is X is combined with weight W, and we got the resultant est. So I have given an example. This X is a vector, and this is just an example, A1, A2, A3, and weight given by E1, E2, E3. So the size of the input pattern should always be equal to the size of the weight. So A1, E1 plus A2, E2 plus A3, E3. This is the inner product, and we store the result in est. So after that, we use the activation function to calculate the output O using est. So this fest can be, if we use the binary class classification, we can use the sigmoid, and we can use softmax if we have to do some multiple class classification. So the weight update the weight updation, before we update the weight, we have to calculate the value of delta. So delta is given by D minus Fs, Fds est, where delta is the learning signal. It's a very important parameter. Once we calculate delta, we update the weight with W is equal to W plus eta delta x. So after we calculate this delta and update the weight, we calculate the cost function, that is the error function. The error is equal to half t minus O square. So we check in the fifth step, we check whether we have used all the training patterns. And if not, we use all the training patterns. Then after that, we check whether the error has dropped down below the desired error. If it's dropped down, then we stop the training. And the weight obtained is the optimal weight that we can use for testing. Now, this is how we derive the learning signal delta. We use the gradient descent algorithm. So gradient, you all know what is a gradient. Gradient of a function is a vector which points in the direction of the greatest rise of the function. For example, I have a function fx, and I want to find the value of x so that fx is maximum. Then what we will do is we will find the gradient of the error. So the same concept we have used here. So our aim is to find the value of W so that the error is minimum. So that's why what we do is we find the gradient of the error function given by dou error by dou wi. Then finally we got this minus d minus o f dash net x. Then what can we update it as? W is equal to w minus eta gradient of the error. And finally we got delta given by d minus o f just net. So this is the code snippet. So what we actually do first is we find the output of the output neuron. So here we can see the input x is combined with w and got the result temp. Then finally using sigmoid, we find the output y. So this is about the learning process. So we pick up a we pick up an input pattern, training pattern. Then we calculate the output by calling the find output. Then after that, we calculate delta to update the weights. Then after we find delta, we update the weight W. Then after that, we calculate the value of the error. So these things, this learning process is going to take place till error is greater than the desired error. So next is the multi-layer perceptron. This is another neural network architecture, the extension of the single layer perceptron. Here in this multi-layer perceptron, we have one output layer of neuron, one or more than one hidden layer of neurons. Then we have one input layer. So as you can see in the figure, so the right side, the extreme right side is the output layer. The middle one is the hidden layer. So we have used one hidden layer, and we have the input layer given by the blue dots. So X is the input. So here we have two types of weight. The first one is the weight V, which connects the input with the hidden neurons. The another type is the weight W, which connects the which connects the hidden neurons with the output neurons, that is weight W. So D is the target output or the desired output. O is the output of the output neurons, and Y is the output of the hidden neurons. So now this is the architecture. Now this architecture can be trained using the backpropagation algorithm, also known as the BP algorithm, which is also an extension of the delta learning rule. So first we initialize the weight, we set the error with some values. Then after that, we calculate the output of the hidden neurons and the output of the output neurons. So after we calculate the outputs, the next is to update the weights. So before we update the weight, we calculate the learning signals. So two types of learning signals we have, one for W, represented by delta K, and the other represented by, and the other for weight V, represented by delta J. So first we calculate delta K given by D minus O F net, F dash net. So two types, one for unipolar, the other for bipolar. Now, once we are done for weight W, we calculate delta J for V. So here, to calculate delta J, we use the learning signal of W, that is delta K. That's why this algorithm is known as the backpropagation. So after we calculate both this delta, we update the weights. W is equal to W plus eta delta Y, and V is equal to V plus eta delta X. Then after that, we calculate the error. and check whether we have used all the training patterns. If not, we use all the training patterns. Then after that, we check whether the error has dropped down then some desired. And this often weights are the optimal weights. So this is about how both the deltas, delta of W and delta of V has been derived. The same process that we have done for the delta learning rule, we have done here. So we calculate the gradient of the error for W with respect to W. And we get the result minus D minus O F just net Y. And weight updation has to be done in as W is equal to W minus eta gradient of error. So this is for W, and now this is for V. So for V, to calculate the gradient of this V, what we do is we find the gradient of the error with respect to V. So we get the result as summation of delta K, WJK, F just net, X. So we use some chain rule here. So we put in the weight update equation, V is equal to V minus eta gradient of error, and finally we got delta J is equal to summation of delta K, WJK, F just net. So this is the fourth snippet. So the first, what we do is we calculate the output of the hidden neurons. So X is combined with V, and the result we use sigmoid and got the output Y from the hidden neurons. So next we calculate the output of the output neurons. So here the input to the output neurons will be the output from the hidden neurons, that is Y, and it is combined with W, and we got the resultant. Then we're using sigmoid for binary class classification, we got the output. So this is about the learning process. So the whole learning process is going to take place till this error is greater than some desired error. So we pick up a training pattern, find the output of the hidden neurons, then find the output of the output neurons. Then before updating weights, we calculate learning signal of W, then learning signal of V, and update the weights W and V. And then we calculate the error. And the whole process continues till this error greater than the desired error. So now let's come to a deep learning architecture. So whatever we have discussed so far, that is non-deep learning architecture. So convolutional neural network, this is a deep learning architecture, and it has three main layers: the convolutional layer, pooling layer, and the fully connected layer. So the main advantage is, CNN we usually use for image classification. So whenever we used non-deep learning architecture for image classification, what we do is we extract features from these images. And using the features, we build the feature map or the input patterns. So here, using CNN, that manual feature extraction will not be required. That will be handled by the first layer, known as the convolutional layer. And it gives a very good performance in it gives CNN has given a very good performance with image classification. So now let's have a look at the whole architecture. So the convolutional layer and the pooling layer, they goes together. So this will be repeated for many times, and the resultant will be passed to the next layer. There is a flattened. Then finally, it will be passed to the fully connected neural network for the classification tasks. So the convolutional layer, so which does the feature extraction and learning, how actually it does. So we will take an image of size n by n and a filter of size f by f. So the resulting size, as you can see in the slide, is given by n minus f plus 1 by n minus f plus 1. So this is how the convolution operation takes place. So we have taken an example of 4 by 4 image with a filter of 3 by 3. So as you can see on the left side, the filter will be placed in the image, and the corresponding elements will be multiplied and they will be summed up. So as you can see, the filter, only the diagonals are 1. So only the diagonal elements will be positive and they will be summed up, and we get the resultant 8. So when we use strides equal to 1, the filter will move horizontally and vertically by 1 pixel. So you can see in the second row, we place the filter there and the diagonal elements will be summed up, and we got the resultant as 10. And finally, we got 6 and 11 after the convolutional operation. So the next is the ReLU operation. It is a nonlinear operation, and actually what it does is it will max all the negative values. It will convert all the negative values as 0. So we also use the ReLU operation. Then pooling layer is used for reducing the spatial size of the representation. So we have 2 types. One is the min pooling and the other is the max pooling. So pooling, also we used a filter, and that filter, as you can see in the slide, is placed in the image. And for min pooling, we will take the mean, like 1 plus 1 plus 4 plus 6 divided by 4, and we get 3. So the filter is moved again by stride 2, then it will be placed in the image, and we got 4, then 8 and 3. This is max min pooling. So max pooling, the same way, we will place the filter in the image and we will take the largest element for the max pooling, and resultant we got 6, 8, 30, and 5. So finally, whatever the output from the pooling layer, it is flattened. So it is like the conversion from 2D to 1D. As you can see, 6, 8, 35 is flattened to get 1D as 6, 8, 35. So finally, the resultant is passed to the next classification layer called the fully connected network. And this is like the multi-layer perceptron that we have discussed in the previous slide. And we, for multiple class classification, we use the softmax function. So with this, we will have a look at some applications of deep learning in healthcare. So this is about classification of oral types and anomalies using CNN. So here, what we do is we use an X-ray called the OPG, orthopentomogram imagist. So using CNN, this OPG image, it contains a set of teeth, 32 teeth, as you can see in the diagram. So when we used the oral and anomalies classification, so what we have to do is we have to do some segmentation of the tooth. Then after segmentation, some image pre-processing has to be done, like cropping, rotation, image scaling. Then finally, so we also use data augmentation to increase the number of training patterns. And finally, it will be trained using the CNN. So the main thing is, if we used CNN, what we have to do is we have to do the individual segmentation of the individual tooth, which is time consuming. So it has been trained in CNN and up to like 1000 epochs, and the error has been dropped down to some 0.2, 0.1. And after that, some performance analysis has been done. So the number of classes used here is 4, that is gap, impacted, incisor, and molar. So 4 matrix has been used: precision, recall, F1, and accuracy. And the final accuracy obtained is around 97.92. So now here, what I want to explain is we have a extended architecture of CNN called the faster RCNN. So this faster RCNN is an architecture or a model which can do object detection. So when we use faster RCNN, we don't have to do the segmentation of the individual tooth. So faster RCNN will detect all the objects, all the tooth, using a bounding box. That is the main advantage. So how we have to do the so first we have the image. Then what we have to do is we have to do the leveling or the annotation using bounding box. And we can use any tools like the VTT or the VIA. So after complete annotation or leveling, then we have to use the faster RCNN for training. So faster RCNN, it has two main subnetwork. One is the RPN, which creates the proposal, and the other one is the ODN, object detection network, which does the evaluation of the bounding boxes and does the classification. So RPN. So first, let's have a look at the RPN, the region proposal network. So it consists a set of anchors, and these anchors are nothing but bounding boxes. So it will create the anchors, the bounding boxes, and using the concept of IOU, intersection over union, it will calculate the value. And if this value is 0.7, it means it is marked as positive. And if this value is lower than 0.3, it will be marked as negative. So this is the concept of IOU. So we have two types of bounding boxes. One is the ground truth bounding boxes, prepared manually using the tool, and the other is the predicted bounding boxes, which is generated automatically. So if the ground truth box overlaps, if the overlapping is more, it means the detection is accurate, and you will have a higher value of IOU. I forgot to put the equation here. Anyway, I will continue. So the next network is the ORDN. So ORDN, it does two things. One is the regression and the classification. So regression, by doing regression, it will determine the predicted bounding box. It will predict the values, calculate the values X, Y, W, H. So X, Y is the position of the point in the box, and W is the width, and H is the height. And after that, after regression, it will, by using the classification output will be the probability P, which indicates whether the predicted box contains the object or does not contain the object. So in this application, we have used 6 types of classes, which are dental types and anomalies, canine, cap, impacted, incisor, molar, and premolar. So the patterns have been trained up to iteration 63,892, and the loss has been reduced, like with a very small value. So this is the output. So in the figure, you can see this is the OPG image, and its tooth, which is an object, has been detected by the bounding box. And also after detection, it has been classified, whether it is smaller, impacted, or incisor, or these 6 classes. And a confidence score has also been generated, as you can see on the left side of the figure, top left. So the object has been detected and classified as smaller with a confidence score of 99%. So this is the performance analysis using the 4 metrics, and the average accuracy has been obtained is around 99.72. So I will so this slide is all about development of an assistive technology for dyslexic children. So dyslexic children, or dyslexia, it is a syndrome where a child cannot read or write properly. So here our focus is on for children who cannot read properly. So the therapists, what actually they do is they used to show a text or an image to the child, and the child will respond or read it. And if the child cannot read properly, the therapist will tell again to read properly till this process continues, till the child can read the text or image properly. This is the manual therapy. So our objective is to convert this treatment automatically by using this ASR and TTS. So how it does is a text or an image is given to the child, and the child will respond. So the response from the child, which is a speech, is converted into text using ASR. Now, using the text, we will generate a response, also using the ground truth. Whether this we will generate a feedback from the response using NLP and the ground truth. So this feedback is nothing but whether the child has properly read or not. That is the feedback. So this feedback will be again converted into text using TTS. Then, sorry, this text will be this feedback, which is text, will be converted into speech using TTS. So then this speech or voice will be again will be fit to the child. So again, according to the feedback, which is in speech, the child will respond again, and this process converting into text, then feedback, then again to speech. This process will continue till the child can read properly. So we're working on this using two languages. One is the Kannada and Manipuri language. So this can be used by blind people. So here we start from the image document. So the image document, we can capture from external device. So after capturing, it will be passed to the mobile. And after it passed to the mobile, the image analyzer, it will check the quality of the image. So if the quality is up to the mark, it will be passed to the next module, which is a document analyzer. So document analyzer will do some analysis of the structure, and it will extract the text in segments. It will extract of the structure. So paragraph wise, it will extract, and these segments, it will be passed. Which is the text, it will be passed to the TTS to synthesize voice. So this is how we are in the process of developing this document reader. So, Dr. Uzal, so this is all from my presentation.
Yes, thank you. Thank you, sir. Am I audible, sir?
Yes, yes.
So, thank you, sir, for your valuable talk. And now I am requesting the participants. So, now I am requesting the participants. So, if you have any question to Dr. Chandra, sir, so Please ask the questions now. Is there any question? Please ask question. All the participants are requested to ask question. If you don't have question, so we'll conclude this session. So I feel there is no question from others. So this is I thank to our academic dean, Dr. Khel Chandra Thangam sir, for his valuable talk. One mostly his focus was on uh, uh, convolutional neural network (CNN) model and mostly other medical issues and real-time challenges and some methods, mathematical background related to that processing to some problem solutions into for the field of healthcare. So you have highlighted the mostly some advanced approaches in CNN and other approaches. So I'm very much thankful for your expert talk here at this faculty development program as a coordinator of this 5 days faculty development program. Thank you so much for the contribution towards this organizing our faculty development program at NIT Manipur. Thank you so much for your involvement, sir. Thank you.
So thank you, sir. And I thank all the participants also. If you have any question, you can ask me anytime. Yeah, not in this workshop. After this workshop or anytime you can call me on phone or whatever.
Oh, okay, thank you so much, sir. So we'll rejoin on the session around 2:40. So again, the session I will start at 2:40. So based on this, we'll rejoin. Okay, so I'm stopping here today. So Sandeep, sir, are you there?
Yes, sir.
Okay, so it is fine. So we are stopping here for this session. So in the next session, I will start at 2:40 p.m. as scheduled. Okay.
Okay, at 2:40, right, sir.
Yes, yes.
Also,
Thank
that
you.
feedback form is available in the chat box. Participants can fill the feedback form.
So it is good always to give us feedback to find some gap here, also some limitation. I feel that I'm requesting all the participants to participate and interact with us because during the session and after the session I am not getting any questions from the participants. So uh, it would be very good for us also when we are organizing this faculty development program with a major objective of cross state development and other things. So I'm requesting all the participants, please raise your question and be involved into that program. So from next session, I will like to ask question also during the session. So please be there and give your feedback every session so that we can improve in future as well. So thank you from my side from NIT Manipur, Dr. Ujjwal Vishar. So thank you so much for participation in this FDP and so we'll resign on 2:40 p.m. today again.
Good afternoon, all. I am Dr. Dennis Merangthem. I'm a assistant professor in CSC and IT Manipur. Today, I will take this privilege to introduce our colleague from NIT Manipur CSC department, Dr. Ujjwal Biswas. He is going to deliver the talk, and a brief introduction about our colleague is that Dr. Ujjwal Biswas is presently an assistant professor in the Department of CSC, NIT Manipur. Prior to joining NIT Manipur, he was the faculty member of CSC in IIIT Bhagalpur. He earned his PhD from IIT Guwahati, Department of Computer Science and Engineering, in January 2024. In IIT Guwahati, he was affiliated with the User-Centric Computing and Network Laboratory. He received his MTech from the Department of CSC, NITTR Kolkata, a very prestigious institute, which is under the MHRD, Government of India, in 2010, and graduated with a BTech degree from BEP, that is the West Bengal University in 2006, with a degree of Information Technology. Before joining his PhD in July 2016, he was working as a software developer for about 2 years at the government of West Bengal, Vikas Bhavan, Kolkata, for support and project under the NIC, that is the National Informatics Center, India, Vidyut Bhavan, Kolkata. In addition, Dr. Biswas has about 6 years of teaching experience in 3 different colleges, including visiting faculty in the Department of Computer Science at NIT Dugapur. He is qualified for UGC NET 3 times in the Computer Science and Applications domain in 2012, 2013, 2014. Also in West Bengal SET in 2015 and GATE in 2008 with an All India rank of 846. After graduation, he has worked for 2 years as a senior software faculty trainer for C, C++, Java, Visual Basics, Advanced Java, and other internal projects. So with this prestigious credentials of Ujjwal Biswas sir, I would like to invite him to deliver his talk on for today's faculty development program. Thank you. Please, sir.
Thank you. Thank you so much for the introduction, sir. Dr. Dennis from our department, except computer science and engineering. So today, what as per the schedule of ours, we are going to discuss. Last day, I have discussed about the topic which was a quantum machine learning and their basic operations. So mostly I'm going to discuss today again for two different things. Mostly I'm going to discuss about the quantum machine learning based activities and some case studies based on the previous day discussion. So let me share my screen before starting the session. So I'm very thankful for all the participants that it was a good number also from all over and India across state. So so I feel that now I'm sharing my screen to present the PPT on case study. Mostly I will focus on two of my paper. So I feel that this is now visible. Yes, this is visible. And now, uh, so today I want to share that here. Okay, so this PPT, yes, where is this? Yeah, no, slide show. Where is this slide show? Where is this? Yes. No. Ah, hmm. So yes, so today's uh, case study based on the first topic, which is IQ HF, which is the title of my recent conference paper on the quantum hybrid framework. So quantum hybrid framework, this quantum hybrid framework is basically we have uh, communicated and we have and this paper is accepted by IEEE third GCON conference at IIT Guwahati itself. So one of my UG student during the open end project, she developed this IQ ASAP framework for secure medical image watermarking. So securing medical image watermarking is very vital now. I feel that why this is very important and vital. The reason is uh, if you take nowadays trend for researchers that mostly digital healthcare already several experts has already discussed that the digital healthcare is very important in the new era of computing and technology because the important techniques and technology and devices all whatever together we are using for healthcare system uh, mostly for developing the rural areas their their healthcare system and healthcare assistance mostly now people are focusing because in India this infrastructure and healthcare issues are there. So mostly today's agenda related to this topic I have shared with you. This is one of the case study from my study that this is introduction about the digital healthcare security. I said that this security also very important role nowadays because whenever we are using digital tools, obviously it should provide some input from the patient side. If that patient side image and other things tempted, that means it is obvious that the identification and disease diagnosis should be affected and maybe the treatment may be affected in future. So there is a chance that whenever you are using a digital system for identifying the diagnosis and advising telemedicine like this, it is very important to make a secure tools for that. So digital healthcare and security landscape is very important in the direction of healthcare system development. Now the research objective secure adaptive quantum and enable enhanced goals. So you see these quantum enhanced is we are just started in India. Mostly every people are trying to use. Beforehand, I have also discussed in my past lecture also that secure adaptive technique related to research objective in the healthcare directions are very important to increase the enhance quality of the healthcare intelligence system. And also the privacy risks and limitation of existing methods are very important whenever we are developing. Due to I said that the tempering the image, the diagnosis totally changed, and other also the authenticity of the image and privacy of the diseases sometimes they take a key role in the direction. So that's the reason for digital watermarking with the help of this quantum enhanced goal. I will discuss more on quantum enhanced goal because in this is a hybrid model or hybrid framework we have developed. So for hybrid quantum enhanced model we have proposed. So in this direction, I will also show some literature review based on my observation and our student who worked for that in the open project in my one of the course. For digital image processing. So in that, we observe that the proposed methodology is very important with the hybrid model of quantum. It reduces the states and as well as the computational complexity. So based on that, I will also discuss the proposed methodology, results, and discussion on the topic, and mostly the advantage and the challenges what we faces to build such adaptive and hybrid model on quantum enhanced technique into a medical image watermarking system. So in conclusion, the key contribution and the key takeaways from the research work based on the paper. So the first of all, these I have digital healthcare and security challenges. I have discussed that in the direction of these MRI, CT scan, and these are the imaging techniques. So if we change the image, totally change the diagnosis systems and diagnosis approaches. So mostly in that direction, it creates a key vital role in the medical imaging system. And the security vulnerabilities is another aspect, which is unauthorized access, image tampering. I have said previously that when someone tempering the image, it is obvious the performance of your tools or intelligence system obviously degrade, and the treatment should be in the wrong direction and wrong way. So that's the reason for why it is important. So that's the reason that why these things are important for that. So next, am I audible? Is there is there any issues? So I want response from the participant. Am I audible?
Yes, sir.
Okay, so fine. So this security challenges and limitation of the encryption. Thank you for the feedback. So limitation of encryption and other approaches. So in this medical image watermarking and research objective, in this I have already said that image MRI, CT scan, medical images as very common in previous research as well. But here DWP, this SBD, they are embedding this in transforming the domain insertions and now this layer 3 watermark output. These are the three layers approaches where what is in medical image watermarking. Uh, I'm not going to discuss in details. However, it is ownership verification only and data integrity. So these data authenticity and authentication and ownership verification is very vital, and data integrity without compromising the diagnostic quality. I said that diagnostic quality things if it is tampering and other things. So in that direction, the data security and other things are very, very important. So making the secure, robust watermarking for medical image is playing a key role from last 2 decades, but now we are going to in new era of quantum enhanced security layer to provide a more better security and image processing to make it possible faster system for the intelligent medical research. So maintaining high PSNR and other values, intelligent residence against the multi-type attacks. So these are the very frequent concepts which are generally used in security. But I'm not the expert. Actually, my research area is not on that. But still, this is computationally secure system. More we focus on implementation and also using the concept of the quantum enhanced security layer in the direction of watermarking in medical imaging. So we focused on more on the properties of the complexity and execution of the system with a high performance and other things we provided, and a more secured enhanced security layer with the help of the quantum machine learning into the medical imaging. That was our major objective for the case study. Now, if I discuss about some few basic importance about the many system. So, if you check this system like a special LSB, DWT, DCT, these are very common. Special low, the robustness and the quantum. So whatever I feel that based on our observation, if you see the last column of the table, it is obvious that quantum machine learning and quantum computing have previous work, no one concentrated on the part which is quantum machine learning to increase the complexity and executing executing faster. So processing time should be reduced. Based on that, we have proposed some hybrid model with a common basic parameter which is previously discussed. These are the very common, and this is starting from the last decade. People are working on these all type deep learning, AI based techniques. These are very frequent, and these are a lot of literature are there in the direction. But I said that gap is there in quantum machine learning into medical imaging is most of the people are not focusing. But in our research, what we observed that many computational execution and complexity reduction may be done with the help of quantum machine learning. This is very basic starting of our research in the direction, but still we observe that there are many opportunities or many challenges may be faced during the implementation and as well as use of the system to build such a system into a real base. So for that identified research gap, we have fixed embedding into the classical approaches into hybrid quantum model to no predictive intelligence absence, AI driven. So no quantum security. This is the observation based on the table. So based on our observation, we find some gap that this quantum machine learning may help. in this direction, and based on that we have proposed this hybrid model. And based on this hybrid model we observed that it helps a lot, and initially it accepted for the conference paper for in this direction. Still we are working on working very hard to implement and enhancing this technique. So proposed framework architecture also, these are the system. These are very common with the generic classical model. If you check the previous any other applications like medical image and watermark system. So the CNN feature extraction is very common. Like everyone talked about the CNN feature extraction, medical image input. So everyone, all the expert, I feel that in this direction they've all talked about, and also image fusion and RL based adaptive optimization. So QNN feedback loop is another important feedback, mostly with QNN use. So here mostly the QNN utilization and making the more secure watermark output based on the input. So mostly these initial ideas was to multimodal image fusion, but now it becomes this the part of QNN which is more advanced, and based on the research gap we have adopted this technique. And we have observed that based on the system or this framework, we have get more better opportunities. So to enhance the system execution time and also the complexity of the system. So quantum security layer, providing this quantum security layer was the most important challenge, and that is our major objective into these problem solutions. So core components, if we think about this, our architecture or framework in the direction of the medical intelligence system. So we observe the CNN fusion, DWTSBD, and DQN agents. So quantum walk. So mostly these QNN, DQC, variational quantum circuit for attack, prediction, and feedback loop. So attack prediction and feedback loop, these are the major challenges what we address in the research objective. So mostly we have also proposed some core algorithm to implement or embedding and extraction of this algorithm. We have proposed in the publications that we have proposed watermark embedding and the watermark extraction also. So for that we have proposed these very basic two algorithms. These are very common for embedding technique is very common, but watermark extractions and recover modified singular values and reconstruct the watermark matrix. This is very common generic features of the any watermark technique. But it is RLDQN role. The DQN agent observes major state. That is our the major challenge we have addressed, and select the embedding strength actions and receive the rewards based on the PSNR and NC, enabling adaptive attack aware optimization. So that was our major objective, and that is achieved to algorithms based on our proposed model or proposed framework. Now, if we think about the quantum security layer, QNN feedback, so quantum walk QW also helps in encryption to generate high entropy quantum key via discrete time quantum walk. So XOR-based encryption of embedded watermark bits, and provide post-quantum and cryptographic resilience. So, variational quantum circuit (VQC) used for predict attack type and in the real time, and feedback quantum inform feedback to RL agent and enables the proactive robustness adaptation. So these are the major concepts which we address in our paper also. So these are this quantum walk encryption is one important part, and variational quantum circuit. Making these variational quantum circuit to utilize it into the system for the hybrid quantum model. So based on that, what we observed that the experimental results and performances and encryption, we observed that experimental results and performance evaluation plays a key role. So, and here, if we check these AUPRC and this accuracy F1 score, these are very common metrics which are used generally to check the model performance. So everyone talked about this model performance and other things. And so I'm not going to discuss about this all in details, but there's no diagnostic quality loss. So PSNR is greater than 42 dB, and NC is 0.95, and AUC is 1. So that shows that in our system, also in our framework, it is working well and fitted well into the framework based on the observation and the result generated. Now, if we check the advantage, challenges, and the conclusion based on the quantum hardware and quantum challenges, mostly what are the key advantages we receive from this work? So we observe that there are many concepts may be implemented in near future to on extending the research work, and also it has opportunities to enhance the quantum hybrid model to produce as a quantum circuit, and from that quantum circuit maybe can be optimized the data volume, and based on this data volume, probably it will help to scale down and time complexity future ready architecture for quantum machine learning. So adaptive CNN and RL intelligence, quantum enhanced post quantum security can be improved. And the challenges we face: high computational complexity. I have also previously included and discussed that we have faced several challenges during the sessions several times. In the first session also, I have talked about the challenges. Here also, these are the very common, that high computational complexity. If you check, high computational complexity is important. High computational complexity and the quantum hardware access limitations. So mostly we have faced the challenge, high computational complexity and crashing the program code, and sometimes we face several challenge that from laptop it is not possible to execute. We have used our workstation. So such real-time challenges may be common for quantum enhanced hybrid model development, and real-time deployment overhead is there. So for real-time application, this overhead should be a higher overhead with respect to the classical methods which are generally used for watermarking for last 22 decades. So future scope, it is obvious that I have said that the future scope, there are many future scope related to these quantum quantum computing or quantum machine learning to enhance the medical system. And also, this quantum neural network now is becoming popular, so into a single intelligent framework. So, achieving a state of the art robustness system, impressibility, a post quantum security for medical image watermarking, in this direction, these works fitted good for the system. So I feel that I have discussed this case study. Now I'm going to discuss other case study related to that of my work. So another case study mostly related to that also I'm going to discuss that is uh, so next probably that one I want to take another topic and another paper. If we check that paper also, that should be one good idea. Maybe I will show some important things from there also. So, so I will show you this quantum ML based. So if you check this, mostly in this paper, also this quantum ML generation, Zen AI we use, and another which I have discussed already, that is the this paper. So in this paper, what I like mostly I will discuss from this paper itself also, because I feel that in PPT maybe something missing. So I feel that this one is very important to discuss here. I have discussed about these two algorithms: watermark extraction and watermark embedding. And if you think about the watermark extraction process, also here in the figure, if you check this watermark embedding process. So these are the basic process for the watermark embedding process. So for host image and DWT composition, these are the figures which are used for demonstrating the embedding process. So I've talked about that how this embedding done in two algorithms. So these are the demonstration how we applied these DWT and into this QML and extracted these with the help of image processing technique. So mostly what I want to discuss is algorithm. I have discussed that algorithm one and two algorithms have two different purpose and two different concept and use. So if you check this quantum security and feedback loop, this is our actual objective. So if you check this quantum variational, um, this if you check this one, only I want to discuss more on that quantum security and embedding loop. So actually, these to enhance security, the final watermark image is encrypted using a quantum walk. I have also discussed, and quantum XOR gate operation, and additionally a quantum neural network implemented using a variational quantum circuit. So these mostly this quantum security provider, and that is our contributions. And if you check these things also, that here if you check this mostly we observe that result and analysis mostly we observe that if you use it, it will reduces the state for a quantum variational circuit. So it will reduces the state. Here we have used only these four state for implementing it into our actual implementation. So mostly we have used this step to implement, and if you do about more research on the topic, so it will help a lot to enhance the actual technique into a QML implementation. So I feel that this is one case study. Now another case study, if I talked about, is mostly this quantum generative AI. This quantum generative AI also important for implementing. So quantum ML and Gen AI, this is also one important topic, which is as a key case study too. I will discuss about the case study too on the topic. So mostly in the direction of this quantum ML and Gen AI in preliminary disease diagnosing. This was the first work on the quantum ML. This we have made a chatbot for implementing it into real base. So the quantum ML and chatbot initially it was built for the computers for helping the remote people like mostly the rural areas like the northeastern state like Manipur. People are suffering from diseases and the poor people are there, so they don't used to try going or visiting the hospital. So based on that, we propose these quantum ML and Gen AI in preliminary disease diagnosing. The most important part of this was we have implemented one chatbot with a NLP. So this technique also helps in healthcare AI, generative AI foundations. Here, when we propose the generative AI, mostly used for segmenting, segmenting the state from the input from the patients for identifying that patient's problem. So mostly in generative AI helps to find the segmentation or segment the part where mostly the focusing the patients through his word or voice. So mostly that was the major objective, how that should be done and how it reduces the complexity for the system implementation. So for system implementation, it is also important. If you check this system implementation with the quantum machine learning and Gen AI in preliminary disease diagnosing. So for preliminary disease diagnosis, also making this chatbot framework, this is one kind of tele medicine or tele assistant to the patient, those who are in rural areas. So that was our initial state, but we faced several challenges to identify identify the problems from the speech to a voice, and then from voice to text, and then from text to segment the actual rising problems from the text or voice segmentation is done with the help of generative AI. And also also some important problem gap finding the execution time for improving the generative AI segmentation and computing in real time. So objective also there I have I will discuss. Proposed framework also architecture, data pipeline, and QML. So mostly in proposed framework, we have used the technique of AI, generative AI, and quantum embedding technique and quantum circuit design that mechanism is implementing with the help of this new generation technique which is quantum machine learning. And also this is very similar that evaluation and result challenge and future scope conclusion is there. Mostly in healthcare AI landscape, waste was the initial idea that it should be of 24 hours to preliminary disease identification. But what was the challenge? What was the challenge that we faced during the implementation and proposing the such system? It was the idea, and it was the challenge of with what basis the diagnosis results should be discussed and advice should be given. That should be very important part of the implementation. So in that direction, what we did, we proposed some PDF reader. So from PDF, it should be generated. Some medical diagnosis and segments should be generated, and LLM work on that. So generate the contextual medical responses based on the medical book. So what was the initial idea was that how into these medical books, that means the doctors who propose and the experienced doctors who have written the book. So maybe for one book, maybe for two book or three book, whatever it is, we provide initial learning to the system, and based on that initial learning to the system, it will work based on the LLM and whatever it is that we are discussing that using the quantum machine learning technique into this. So making a patient and enable natural language symptom assessment. I have said natural language symptom assessment was more challenging initially we faced. So based on our identification, we observed the major challenge is rule-based chatbot creation. With the help of this natural language processing, NLP comes into the field, and then this build a GNI based Gen AI based powered preliminary diagnosis chatbot. That was the challenge we faced. So major challenge was classical NLP embedding into a training into a high dimensional data computational expensive in the last previous research work. But based on the observation, what we observed that maybe that can be enhanced based on the classical NLP embedding into Gen AI and quantum enhanced semantic embedding system into that system, and to reduce the computational overhead via low dimensional and quantum vectors. I have said in generally what was the observation. In general purpose technique we use generally 300 400 state, but in our case we have used only four quantum state, and that four quantum state is also what fine for the system. So I feel that if it is computationally, if we build some more technique into it, we can enhance the system itself more better, and in computationally it should be most less complex than the previous one. So reducing the computational overhead via low dimensional quantum vectors. I have said that here we have used only four low dimensional quantum vectors. So low dimensional quantum vectors helps to identify, reduce the computational overhead. But in general, generic computational technique and classical technique use only a no, huge number of states, like 300 and more than 300. Always it takes much more complex. And in quantum enhanced semantic embedding reduces the dimensional low dimensional quantum vector. So that helps to improve the patient interaction with the context LLM and responses in a real time. So based on these, we have observed, we have checked the literature also in the direction, and during the proposal of this also, we observed, says one of my MTech student who worked on that, and we finally proposed that Gen AI plus QML. Gen AI is very common for all medical systems and medical analysis. Not only this medical analysis and other things, also Gen AI is very popular nowadays. For every field, they are using this generic Gen AI for any identification or prediction. But in our case, we have combined this quantum machine learning and Gen AI, and we got a higher response and reduces the time complexity. So based on that, we feel that the rule-based systems, symptom checkers with a scripted logic, and deep learning NLP is always required. LLM is chatbot is required. Existing gap, no framework combined with Gen AI with a quantum enhanced semantic retrieval. I said that why this quantum enhanced semantic retrieval diagnosis is important. I said that the reducing the time complexity, not only the time complexity, it should be reduce the state. So only for variational state in quantum circuit we use for that. So it helps to reduce the time complexity for implementing into a single framework or into a advanced level framework with the help of Gen AI and QML. So mostly we observe that this helps a lot, and that proposed framework is mostly, if you check in the quantum embedding, this quantum embedding is our contribution. If you check this one our contribution mostly. But user query and text processing, these are very common for any application, any intelligent application. So for any intelligent application, these are user query and text processing are very common for any chat GPT or any feedback type application for any intelligent system. But this quantum embedding is our approach, which we try to reduce the vector retrieval, and this reduced number of vector retrieval helps to reduce the complexity, and RAG response helps to RAG based LLM to embedding into actual real-time system into that to enhance the timing. So our text processing pipeline into that. So that was the idea for reducing the vector storage, and the basic idea was reducing the memory, and as well as reducing the time complexity both for these both applications. So in this direction, this step one, I have said this PDF document should be scanned, and if it is available or we can perceive the purchase the PDF book if it is obvious that that book should be a popular and well-known book and in the direction of diagnosis that make a key roles in that direction. Only we'll use that. Otherwise the problem again, the people will ask question how your system should be secured and your system should be acceptable by the people itself. Maybe this in the direction of people diagnosis the properly. So how you making the people secured and why you will use your system. So how your system works based on what analysis, one what disease identification done, what disease symptoms is used. So there are many challenges we face to address in the implementation of this medical chatbot for the people, for the rural people. So yeah, and another concept which is escape-free text chunking is important. This is very common, but a step for this embedding the circuit generation and also the vector storage, reducing the vector space was the one important aspect the of the problem solution. So this I feel that this one is quantum ML and embedding generation. This is the circuit of quantum ML. I have said that this low dimensional fidelity semantic embedding, overcoming the force of dimensionality in classical NLP. That was our objective, and I have said that 4 qubit circuit workflow. We have maintained 4 qubit workflow circuit for the implementation. So this qubit circuit workflow we have maintained with the help of Pauli Z measurement and 4D segmenting vector CNOT gates and RY rotation gate encoded into the actual implementation, and text to ASCII vector normalization is used for actual qubit circuit generation. And in the finally this RAG integration embedding the index in the uh, Pinecone and DB for fast generating the medical knowledge retrieval. So with the help of this quantum ML and embedding generation have changed our objective. So mostly what was our objective, accuracy, precision, recall, F1 score, cosine similarity, ROS 1, this. So these are all the parameters to identify the actual matrix, actual embedding into the chatbot we have used, and these are the key findings we have observed. 100% recall, zero misdiagnosed in the test set, and also F1 score was moderate like this, 91% strong precision recall balance. The cosine similarity also there. So I feel that this model may be enhanced. I observed that may be enhanced again to implement into the actually implementing in the system. So chatbot application in telemedicine is very common. So that may be used into telemedicine and uh, medical analysis, and also that can be done. So advantages and challenges and future scope. It is obvious that there are huge challenges to implement it into a real application into the research area. Mostly the advantages of this such system is low computational cost with the quantum embedding. Oh, that is what was our the major objective into the system. and also superior semantic understanding and retrieval. Understanding means here understanding the people in the direction of from their speech to text and converting into segment and make it scalable and generic system for the people. But it is obvious that there are many challenges during that implementation. So scalable real-time patient interaction, making this scalable real-time patient interaction was one of the major challenge into real chatbot creation. And also supports early disease prediction was another direction. But in future, maybe variable device integration for continuous monitoring, PCOS, chronic disease prediction extension may be done with the help of embedding this quantum machine learning and multimodal chatbot for regional accessibility. I said that in regional language, still people are working on the language processing system itself. There are many challenges to train the local language, and based on this local language, converting this into a natural language processing plays a key role in the direction. So multilingual chatbot for regional accessibility may be one of the next generation challenge which can be people address in the direction of the in the medical system. Also, the real hospital deployment and clinical validation. So we are facing, and where we are also means we are also collaborating with the people, those who are working in the medical system. Maybe in Manipur, we have collaborated with the RIMS, a regional institute medical. So at Manipur, Imphal itself, we have also collaborated for extending such system, because validation, clinical validation is very important when you are we are you are proposing some chatbot and in telemedicine system. So in that direction, the cooperation between the expert, medical expert into the technician like researcher, so that cooperation and collaboration is important. In this direction, maybe people work more for enhancing this problem maybe in future. So challenges, data privacy, ethical concern. I have already discussed in my previous talk also that data privacy, ethical concerns, AI bias, and also the regularity of complaints for medical AI. The complaints of medical AI, I have said that people will tell you in which direction, which topic, why this is right, that your system performance. That is again the clinical validation. So for clinical validation is a major challenge in India also, not only in India, overall global, the clinical validation always takes a lot of time and efforts for people. So in this direction, if medical practitioners come forward and can be addressed. So in conclusion, I can say that Gen AI and quantum ML delivers a scalable and accurate preliminary disease framework, transforming the accessible healthcare. And also, this is very common that it was accepted in IEEE CIC in 2025, and quantum ML then AI in clinical disease diagnosis. This is one of my conference paper also. So I feel that both two application are very advanced applications of the medical diagnosis. So sequering one case study was on the sequering the concept of medical image and other things, to remove the tampering and other security issues, authenticity in the medical image and diagnosis. But the second work which is basically a real application with the people, for helping people with a locality or multilingual chatbot for such application are very important, and this is I feel that this is a very this is important, and this have just started the speed. So I feel that in this direction, if you work, and it will help a lot for the people at India, yeah, mostly population, high population country. For that, it will help a lot for the India to globally improve the healthcare system. So with that, I will thank you once again for the all participant from my end. It is done for two case studies, and the circuitry I have said there's quantum machine learning to implement it. Mostly that is the major challenge. So in future, maybe I am looking forward to collaborate with you people, like anyone, those who want to collaborate with me for enhancing our system. Maybe I will welcome you for that also. So I'm very happy that this is our two advanced paper, which is in the direction of the theme of the faculty development program, in the 5 days faculty development program. These are suited. So thank you to all. If you have any questions or anything more than that, you can mail me, or you can also you can message me in the WhatsApp or whatever it is. So I am sorry for not sharing the last PPT because I was very busy. Sorry for that, related to the evaluation, which is for the BTech UG course and other course evaluation and grading. So obvious that I am sorry from my side that I will share all these PPT by today night. Okay, so with that, I'm thanking you all. And if you have any question to me, you can ask now. So, Sandeep sir, are you there?
Yes, sir.
So again, no question. I feel that participants are not asking any question. So, is there any question from your side, another? So,
Sir, one question, yeah, somebody has asked. It's in the chat box.
okay, sir. Is it possible to use PML for retinal OCT feature restriction? So this, yes, you can use this. Sir, is it possible to use a QML for the? No, my audio is off maybe. So the So am I audible now?
Now audible, sir.
So the question is, sir, is it possible to use QML for retinal OCT feature extraction? Yes. Yes, it is possible to use that, but you have to keep in mind that how you will map that problems into qubit or quantum state and quantum circuit. That is required to convert your. That is the major challenge only, but everything is very similar with the classical approach, and I feel that in classical approaches they use very common things what mentioned here in the message. So it is possible to use that. That is my answer from my side. So any question? So, no. So no question. So we can stop here. But maybe maybe I don't know. I have taken almost 3 hours on this FDP due to the initial problem. But yes, uh, so there are no questions from the participants. So we are stopping here. And feedback form also shared with you for the session. Already you give feedback. I said that this is very important for future FDPs and personal improvement of mind, and also keeping the people that what are the challenges you face. I know that online mode always there should be some challenges. Maybe I'm not always interacting with the people physically. That challenge should be there, but yeah, we have to understand the challenge. But I feel that it is good if you communicate also during my session, also and other sessions, that participants are not interacting. That is my observation, and that is my advice you to all to interact, so that the people also the experts should get confidence, so that they can try to improve the quality as well. So not like that for interacting means giving feedback always and asking question. Any generic feedback also fine for the participants. So I feel that this is very important for any FTP, and if it is hybrid mode, the major challenge I observe, and this is not my first FTP in hybrid mode. So I know the major challenge, while the challenges are, but I feel that anyone who wants to interact, simply interact with the people very freely, so that we can improve our FDP quality, and also you will get something from the FDP. That is the expectation for mine. With that aim, we have proposed the objective of our FDP. So I feel that in future, from tomorrow or today, if you interact more, it will be very helpful for all. Okay, so with this, I, I'm concluding today's session. So thank you for your patience and registering into this faculty development program. So be there, and please attendance. Probably the Sandeep sir take a note that attendance is less, around 51. So I don't know if it is going less 50%. So I don't know. We have to also evaluate them performance and attendance. So take a note on that and request in the in the WhatsApp group that you attend. Okay, sir.
Yes, yes, that attendance is very low, I think. It is only
Okay.
50%. Registration.
Okay. So
So
that
also
is
you have to give the certificate only if they are getting 80% or more than attendance.
yes, yes, no problem, sir. So
Also, we should check the feedback form also.
okay, so fine. So we are stopping here, and tomorrow again we will start. And tomorrow is the final day of this FDP. So I hope that you have enjoyed these 4 days. So next last day on tomorrow, I want to see the participants maybe more on tomorrow. So whatever it is, it should be good to see the number of participants here. So thank you all. So I'm stopping this session here with very common generic knowledge to you. I feel okay. Thank you.